Here we have two exercises, 25 and 26, from our textbook. I've paired together. They look to be the same diagram, but they're really different. They both look like parallelograms, but they're not. Take a look at the diagram in 25. AB and DC are parallel. We don't have any other information, so the figure could look like this. Okay, now look at the other figure. I've got DA and CB are parallel. The figure could look like this. So again, they're drastically different. Let me give you another way to visualize it. Let's just answer these. In the first one, 25, I'm going to extend these lines so we can maybe see the parallel lines and the transversals a little more clearly. I'm going to hide these lines. Let me accent. AC is a transversal and DB is a transversal. So when I'm looking at that, I see two pairs. I see right here a pair of alternate interior angles that are congruent, and I see over here another pair of alternate interior angles that are congruent. Let me restore the original drawing, and it would look like this. I'll trim that up and add those segments. There you go. You've got two pairs of congruent angles, the red and the blue, by alternate interior angles theorem. Now, over here on 26, a little bit different. I'm going to look at this and I'm going to say, well, okay, these are my parallel lines. So in each case, AB and DC are going to be my transversals. Let me clean this up by hiding these. They don't really matter in this picture. Your supplements are going to be here. The green angles will be supplementary. The red angles will be supplementary. Now, I've done that so you could, illustrating it with the numbers. Of course, you won't be able to use numbers 5, 6, 7, and 8 because these diagonals are going through there like that. So we're going to have to use the letters, use the three letters on each. Angle DAB is congruent to angle supplementary to ABC, just as ADC is supplementary to BCD. Well, let's see if we can make sense of this diagram. I've got my parallel lines right there, and I've got two transversals. I've got this one, and I've got this one. Let's start with this transversal, and there's a relationship between these two angles that I should see, and they are, of course, alternate interior angles, and therefore they're equal, so x must equal 45, or x degrees is 45 degrees, either way you say it. Well, there's another set here. I've got these two, again using the same lines, same pair of parallel lines, but this is my transversal. So now those have a relationship, and you should see that they are corresponding angles. So again, those are equal. Y is 85. X 45, Y 85. Well, let's do some algebra. I've got a diagram here where I've got this segment parallel to this one. Well, that makes this a transversal, with these two are consecutive interior angles, and the same for the two angles down here, transversal, and this one and the right angle are consecutive interior angles. That sounds like a job for Theorem 3.3. We know these angles in both cases are supplementary, so we'll set this expression 3y degrees plus 6y degrees equal to 180. We'll drop the degrees and just go to algebra here, and therefore 9y is 180, and you know the rest. Y is 20. Easy enough. Well, let's look at the other one. Now, I know this is 90 degrees, but I'll be a little more formal, and I'll just state 2x degrees and the right angle equals 180. Same thing. So 2x, dropping the degree sign, 2x is equal to 90, and each x must be 45. And we're done. All right, let's get started on this one. I've got parallel lines right here, and that means I've got a special relationship there. Yes, those two are, of course, corresponding angles. And that means, well, x is 65 degrees. So now I've got to do something a little bit funnier. I've got to find y. Now this one's a little trickier. I've got these three. If you look at this, they all add up to this line here. They all have to add up to 180. That's one way I can do it. Alternatively, I could say these two are vertical angles. These two, together with this one, are consecutive interior angles with this transversal. Either way, the three of these have to add up to 180. So let's just do that. So I could list either angle addition or employ vertical angles. Either way, I'm going to add them all up, and let's just do that. So I can substitute. I know that x is 65 from the previous exercise. Combine the terms and then subtract the 120. So I've got 65 and 60 for x and y respectively. Well, let's look at this figure. I've got three parallel lines, but really only these two matter. I'm going to start here with this transversal over here, and clearly these two angles are in the corresponding position, so they have the property of being corresponding angles. There you go. And I could say 3x degrees, 60 degrees, and that simplifies that x itself is 20, the number 20. All right, well that's easy enough. And how about these two? So, well, they have nothing to do with the other variable. We can just solve these all on their own. And they are not corresponding. Those are on the same side. They're on the interior, same side of this transversal. So those would be consecutive interior angles, and they're supplementary. So I'll add this plus this, set it equal to 180. And how you do your algebra is up to you. I'm going to combine these terms a little bit, and then I'll just proceed like that, and we're done. So there you go, 20 and 10 for x and y. Well, let's solve some more algebra. Our parallel lines now are here and here, and I've got two transversals, this one and this one. Let's first look at this transversal. These two angles right here have a special relationship, and we know that they are alternate interior angles. Parallel lines makes those two congruent, which means they have the same measure. Solving for x is 13. That was pretty easy. Now, using this transversal and the fact we've got a right angle down here, we know that the other angle must also be a right angle. Consecutive interior angles are supplementary, so that means that these two have to add up to 90 degrees. Now I've already substituted, or I can replace the 4x with, well, with what? With the 52, because they're alternate interior. So I add those all up together, and they're equal to 90. That's pretty good. And let's see how that works out. Right there, I can just do a little bit of arithmetic, and let me solve, and y is going to be equal to 12. And we're done. Well, here we go in exercise 32 with two pairs of parallel lines. And, well, I guess I'm going to start over here because we've got two variables that match. We've got x's here. So let's use these two pairs of parallel lines cut by this transversal. And if you look at that, there's a relationship, and you should see that these are on the same side of the transversal, and they're on the interior. They are consecutive interior angles. So I'm going to add this and this, set it equal to 180 degrees. So let's just go through all the algebra. You all know how to do algebra by now. And x is 10. All right, so we've got that far. And now for the y. You know, we could write it in terms of x, but let's just take the easy way out. I'm going to evaluate this expression. 14 tenths minus 10 is 130 degrees. Then I'll take advantage of my vertical angles theorem to say that this angle is 130. And now I've got these two angles which have the same relationship, but to this pair of parallel lines. These two, and this transversal, these two are going to be my consecutive interior angles. So there you go. Let's write it out there. I'm going to take this angle and this angle, add them equal to add them together, set them equal to 180, and you know the rest. Just algebra. So 10 and 25 for x and y respectively.